Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an associate professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering. So today we are going to discuss or we are going to solve some numerical problems based on ABCD and H parameters. So as we know, these ABCD parameters are also called as a transmission parameters, and the H parameters are the hybrid parameters. So we have already discussed how to find the ABCD parameters and H parameters. Okay, I mean for a given two-port network circuit, right? So first, let us go with the first problem. So which is determine the transmission parameters in the S domain for the network shown in figure, right? So first they have given one circuit, and for that particular circuit we are going to find the transmission parameters. So the transmission parameters are nothing but ABCD parameters. So as we know, the ABCD parameters are, I mean, the input voltage and input currents in terms of the output voltage and the output currents. So that we need to find. So first of all, here we should convert the given two-port circuit into the S domain. So for that, here only, of course, the parameter which is depends on the S domain configuration. Here it is the capacitor. So here I have just converted the given two-port network into the S domain configuration, so that here the what is that, the 1 farad capacitor is replaced by the 1 by S ohms. So now already the two resistors are there. The input side one resistor which is 1 ohm, and the output side resistor is another 1 ohm. So here for our simple understanding purpose, so for the port 1 having the voltage of V1 and current of I1, and similarly the port 2 also having the voltage of V2 and current of I2. So now, as we know, because we have already discussed the procedure to find the ABCD parameters, the same way here also we are following to find the ABCD parameters. So for that, first let us find the parameters of A and C. Okay, so how we can find the parameter A and C? So like the parameter A and C. Okay, so how we can find the parameters A and C by using, I mean by making the output terminal of the given circuit as an open circuit, which means here we are considering I2 is equal to 0. So from the given circuit, so let me draw here 1 ohm resistor is there, and here let us consider, I mean we have already converted into S domain, so this one, and again here another 1 ohm resistor is there, and this is the given circuit. So in this given circuit, first of all we are going to find the parameter A and C by making the port 2 terminal as a open circuit. So here this is port 2 is V2, let us consider here plus and minus, and again here it is 1 ohm, and here it is also 1 ohm, and here the input current is I1, and again in the input voltage is V1. So let us consider we are connected the input voltage V1 to the port 1, and here it is 1 by S ohms. Then here the current I2, so we are making it is open circuit, so here I2 is equal to 0, the current I2 is equal to 0. So by using this circuit, now we are going to find the parameters A and C. So as we know already, so the parameter A equation, A is equal to V1 by V2, okay, by making I2 is equal to 0. And the similar way, the parameter C, which is equal to I1 by V2, okay, by making I2 is equal to 0, right? So now then how to find this V1 by V2 value? Okay, so for that here, first let us find here I1. Okay, so as you know, this is I1 is the total current which is flowing through the circuit, and then I1 is equal to V1 by the total what is that impedance present in this particular circuit. So anyway here the 1 ohm is connected to the open circuit, so that's why here we can neglect this 1 ohm resistor. Then here the current I1, which is equal to the total voltage. Here let us consider V1, okay, for this particular circuit. Then V1 by here 1 and this 1 by S are connected in series, so 1 plus 1 by S, okay. Then if you simplify this, V1 by here S plus 1 by S, so which is equal to S into V1 by S plus 1. Okay, so then now as we know, and let us find V2 also from the second circuit by applying the loop analysis for the second for this particular circuit. So anyway here I2 is equal to 0, so only we are having I1. So V2, which is equal to, is nothing but the voltage across these two terminals. So the voltage across these two terminals, here it is, the current flowing through this is I1. So I1 into 1 by S, which is equal to I1 by S, right? So now we know the value of V1 and we know the value of V2, right? If you are, because from this here, from this here, so V1 is equal to I1 into what is that, S plus I1 into S plus 1 by S. So we know the value of V1 and V2. If you substitute here, then you will get the V1 by V2, okay. So which is equal here I1 into S plus 1. So here then this S gets cancelled. Then V1, here it is I1 into S plus 1 by S by here V2 is I1 by S, okay. So here S gets cancelled, I1 gets cancelled, then you are getting S plus 1. So which is nothing but here the parameter A is equal to V1 by V2, which is equal to S plus 1. So this is how we can find the parameter A by using this. Then in the same way we can find the parameter here we can find the parameter what is that, C, okay. C is equal to here I1 by V2. So we know I1 here and we know the V2 value, okay. So if you substitute again in these values here, okay, then you will get C is equal to I1 by V2. So here I1 is in terms of V1 here and I1, okay, I1, from here, from this way we can find here. So from this I1 is equal to what is the value of I1, which is equal to S into V2. Then substitute this I1 value here, then you will be having here S into V2 by V2. Then V2 gets cancelled, then you will be get S. So here now C is equal to I1 by V2, which is equal to S. So now we have calculated the value of A parameter and the C parameters, okay, by making the secondary terminal as an open circuit, right? So now in the second case, okay, now we are going to find the parameters of the B and D. So we know already the parameter B is equal to V1 by minus I2 by making V2 is equal to 0, which means we should make the output terminal as a short circuit. And similarly here D is equal to I1 by minus I2, again by making V2 is equal to 0. Then again here I am drawing the circuit. This is 1 ohm, again here it is 1 ohm, and here it is 1 by S. So here I am making the secondary terminal as a short circuit, and this is again I2, so that here V2 is equal to 0, and here it is 1 by S ohms, and here it is 1 ohm, and here also it is 1 ohm, right? Again, the input terminal, similarly like in the previous case, this is I1. Okay, so here now let us consider here it is V1 that we have placing, and again here it is plus minus, and here it is plus minus, right? So now the same way here, applying the current division rule, because here I1 is there, but because we know already I1, so let us consider then I2 is equal to, here I2 is equal to the total current, let us consider here it is I1. Okay, in because here both are in opposite direction, so let us consider here it is minus I1 into what is that into here it is 1 by, I mean actually 1 by S by 1 plus 1 by S. Okay, so if you simplify this, let us write here it is, so 1 by S, because the opposite resistance here it is 1 by S, and the total resistance is 1 plus 1 by S. Okay, and if you simplify this, then 1 by S by 1 plus S by S, so S gets cancelled, so here you are getting minus 1 by 1 plus S. This is I2 value. Okay, so not mine, I mean minus I1 by 1 plus S. Then here, from this we can find D, I think so, because here I2 is equal to minus I1 by 1 plus S. Okay, so then from here D. Okay, so from this you can find here D is equal to I1 by minus I2, which is equal to S plus 1. So this is how we can find the value of the D, I mean the D parameter. Then now the B parameter, here it is V1 by I2. So for that, let us find here the total impedance by taking here V1 as the source. Then the total impedance means here these 1 ohm and 1 by S are in parallel. Then this parallel combination is series with the I1. So then Z is equal to here, we can find the Z is equal to 1 plus 1 into 1 by S by 1 plus 1 by S. Okay, so here by simplifying this, you will get here S plus 2 by S plus 1. Okay, so this is Z. So Z is equal to, as you know, which is V1 by what is that I1, because let us consider here it is the total impedance, so which is equal to V1 by I1. And then as we already know what is I1 is equal to, so from this here I1 is equal to V1 into S plus 1 by S plus 2. From this equation, I1 is equal to V1 into S plus 1 by S plus 2. So as we know here, then we can write here it is I1 is equal to minus I2 into S plus 1. Okay, so which is equal to which is equal to here V1 into S plus 1 by S plus 2. So that here then you will get the B is equal to, okay, V1 by minus I2. Okay, so from this you can find I2 is equal to I1 by S plus 1. Then substitute here, you will get the finally the value is S plus 2. This is the value of B. So this is how we can find the ABCD parameters, because as we know, let us write for a reference purpose the ABCD parameters. So here V1, which is equal to A into, in terms of what is that, input voltage and input current. So input current and output current and output voltage here. Okay, so A into I2 plus B into I1. Okay, I mean B into V2, and similarly C into I2 plus D into V2. So that way we can find the ABCD parameters, so which are also called as a transmission parameters. Then let us go with the second problem. So here also find the transmission parameters for the given network shown in the figure here. So for this particular network, we have to find the transmission parameters. So again here also the same way. Okay, to find A and the parameter A and C, we need to make it the output terminal or the secondary terminal as a open circuit, and again to find the other two parameters like B and D. Okay, so we need to make it short circuit the secondary terminals. So by considering these two cases, we can find A, B, C and D parameters, right? So first let us find the parameters of A and C. Okay, so to find A and C, we have to make it the output port as open the output port. Okay, so which means, okay, open the output port, okay, which is output port 2. So here, then by making the output port 2 as a open circuit, so here let me draw this circuit by making the output port is equal to 0 and by considering this one. So here let me draw here. So here I have just considered the same problem. So here the extra thing here it is, we are considering this V1. Okay, this is here it is V1 and I2 is equal to, because open circuit, I2 is equal to 0 and V2 is there, right? So now let us apply the KVL to the input loop. Let us consider here it is the input loop, okay, and here it is the output loop. So let us apply the KVL. Okay, so KVL to input loop. So if you apply the KVL to the input loop, so V1 is equal to 1.5 kilo ohm. So 1.5 into 10 to the power of 3 into I1, because here the current is flowing in the loop 1 is I1, plus here it is 10 to the power of minus 3 into V2. Already they have given the current. So 10 to the power of minus 3 into V2. Let us consider here it is equation number 1. Okay. So I'll also apply the KCL at a given node. Okay. So when you apply the KCL at a given node, because here let us consider, because here it is not a closed loop, so we can't apply the loop analysis. So then KCL at a given load, here it is 40 into I1, already the current source they have given, plus, okay, so here the voltage is V2, let us consider. So plus V2 by, here the 40 kilo ohms resistor is there. So 40 into 10 to the power of 3 equal to 0. So let us consider here it is equation number 2, right? So from this equation, we can find I1 value. Okay, so then I1 from the equation number 2, I1 which is equal to here minus V2, because we are sending this to the right hand side, minus V2 by here 40 into 40, here it is 160. So 160 into 10 to the power of 3, which is equal to minus 6.25 into 10 to the power of minus 6 V2. So this is the value of I1, right? So then substitute the value of I1 in equation number 1. Substitute the value of I1. So substitute I1 in equation 1. Substitute I1 in equation 1. Then here the equation 1 will become, so V1 is equal to 1.5 into 10 to the power of 3 into in the place of I1, so we can substitute here it is minus 6.25 into 10 to the power of minus 6 plus 10 to the power of minus 3 into V2, right? So which means here we have eliminated the value of I1, right? So because we know the parameter A, which is equal to V1 by V2. Okay, so if you simplify this, then you will get the V1 which is equal if you simplify this, then here you will get V1 is equal to minus 8.375. So minus 8.375 into 10 to the power of minus 3 V2. Then from this here we can find V1 by V2, which is equal to minus 8.375 into 10 to the power of minus 3. So which is A is equal to. So this is the way we can find the value of the A, right? So which means here we are doing just some basic rules that we are applying, because as we know already A is equal to V1 by V2. So either we should write the equation of V1 in terms of V2 or V2 in terms of V1, so that we can eliminate any one of the, V1 and V2, so that we can get the value of the parameter A. Then now we need to find the value of the parameter B. To find B and D, now we need to make the output port as a short circuit. So for that, again, let me draw here. This is 1.5, and here there is a voltage source that we are considered. Let us consider it is V1, and then there is a what is that dependent voltage source, which is 10 to the power of minus 3 into V2. Okay, and then here again there is a dependent current source. Here the value of the current source, here it is 40 I1. Okay, right. Then again here it is one more resistor is there, which is I think 40k, so 40 kilo ohms. And then we are making the output terminal as a short circuit, so which means here V2 is equal to 0, and here there is an I2, so plus minus, and here it is I think here it is 1.5 kilo ohms, and here it is I1, so plus minus, and this is the circuit to find the parameters of B and D values, right? So here let us what is that, consider the nodes. Here it is A and here it is B. Let us consider, right? So apply the KCL. Apply KCL at node B. So if you apply KCL at node B, already 40 into I1 is there. So 40 into I1 plus, anyway I2 is equal to 0. So is 0. So we no need to consider. Then the total current here it is plus 0, which is equal to I2. So from this here I2 is equal to 40 into I1. So we know that D is equal to minus I1 by minus I2, sorry, minus I1 by I2, so which is equal to minus 1 by 40. So this is the value of D. Directly we can find by applying the because we need to make the, because already here there is a dependent current source is there, so that's why it is very easy for us to find the value of the D, right? Then now we need to find the value of the B. Okay, so for that here we are applying the KVL to the input loop again. Okay, so the KVL to the input loop, then here the same way, here V1 which is equal to, already we have applied 1.5 into 10 to the power of 3 into I1. Okay, 10 to the power of 3 into I1. Okay, so applying KVL to the input loop, that we will get, because of course here plus 10 to the power of minus 3 into V2 is there, but here V2 is equal to 0. So that's why we are not considering the V2. So in the second case, V1 is equal to 1.5 into 10 to the power of 3 into I1 only. So from this, because already we know that B is equal to minus V1 by I2 plus V1 by minus I2 at V2 is equal to 0. So from this equation, then we know minus 1.5 into 10 to the power of 3. Okay, by here I2 is equal to minus 1 by 40. So we will get 40. So which is equal to minus 37.5 ohms. So then here B is equal to V1 by minus I2, which is equal to minus 37.5 ohms. So in this way we can find the value of the B. So now we got the value of A, B, C, D. So again let me conclude for any given network. Okay, so if you want to find the A, B, C, D or the transmission parameters, okay, so to find the parameters of A and C, so we have to make output as a open circuit, and for the B and D we have to make it output as a short circuit. Okay, so by using these conditions you can find A, B, C, D parameters. So move to the third problem, which is related to the H parameters. So now we are going to find the H parameters for the given network, right? So here H parameters are input current and output voltage. I mean, one is input parameter, another one is the output parameter. So to find the H parameters here, first of all, let us convert, because this is the delta network. So we know already how to convert the delta network into star network. Okay, because here all the resistors are having the same value. So that's why simply to convert the delta into star, so we can just make it 1 by 3 into R. So which means here 1 by 3 into 12, so that we can convert this star network, because here it is very easy to find the H parameters for the star network compared to the delta network. So that's why here first of all I have converted the delta network into star network, right? So first let us find out, of course here also, suppose if you want to find the input parameters, like there are 4 parameters are there, like H11 comma H12 and H21 and H22. Okay, so first let us find the parameters of H11 and H21. Okay, so by making output output port as short circuit. Okay, then let me redraw the circuit, okay, by making the output port as a short circuit. So here it is having a T network and or the star network, and having the equal resistances, which are 4 ohms, 4 ohms, and again here it is 4 ohms. So we are making output terminal as a short circuit. So by making the output terminal as a short circuit, so here I2 is equal to 0, sorry, V2 is equal to 0. So here there is I2 is there, and here V2 is equal to 0. And let us connect here one current source. Okay, so here it is I1. Okay, then the direction of the I1 is here, and again the V1 is there, right? So here to find this, first of all we should know H11 is equal to V1 by I1 by making V2 is equal to 0. And similarly here H21 is equal to I2 by I1 by making again V2 is equal to 0, right? So for that here, suppose if you want to find the total current, total voltage V1, which is equal to I into the total resistance here, the 4 ohms, which means 4 plus 4 into 4 by 4 plus 4. Okay, so then this is equal to 4 plus here it is 2 into here it is I1. Okay, so V1 is equal to 6 into I1. So then here I1, if you send this one, then here V1 by I1, which is equal to 6, which is equal to H11. Right, this is the way we can find what is that V1 H11. Then similarly I2 and I1. So then let us find I2 in terms of I1 by using the current division rule. So here I2 is equal to, or because opposite direction, so let us consider minus I2. Minus I2 is equal to total current I1. Okay, so anyway both the resistors having the same value, so 4 by 4 plus 4, right? Then here minus I2 is equal to I1 by 2. Then you know here I2 by I1, so send this one. Then I2 by I1, which is equal to minus 1 by 2, which is equal to H21. Right, so this is a way we can find H11 and H21, very simple. Then coming to other two parameters, so for the second parameters, which are H12 and H22. So to find H11 and H22, okay, H22, just what is that, open circuit the input port, right? So then let me redraw by open circuit the input port here, the given circuit. So here let us connect the V2 here, and then I2 is also there. So here it is 4 ohms, and here it is 4 ohms, and here it is 4 ohms. Then we are making open circuit, so that here I1 is equal to 0, and here it is V1 is there plus minus, right? Then first we should know the equation for H12. So H12 is equal to V1 by V2 by making I1 is equal to 0, and H22 which is equal to I2 by V2 by making I1 is equal to 0, right? So then here by using the voltage division, so as we can see, because here the voltage across is 4 ohms and 4 ohms, so V1 which is equal to the total voltage, here it is V2, so V2 by, because here the V1 is the voltage across these 4 ohms, so okay, so then the total voltage is, here it is V2, so V2 into 4 by 4 plus 4, so that we can get here V2 is equal to V1 is equal to V2 by 2. Then V1 by V2, so just send here. So V1 by V2 which is equal to 1 by 2 which is equal to H12. Right. Then now we need to find H22. So to find H22, we know just find V22. I mean the total what is that voltage V2 in terms of I2, because here I1 is equal to 0. So I2 into 4 plus 4, because here these 4 ohms and these 4 ohms are connected in series. So 8. So V2 is equal to 8 I2. Then here just send this one, and here it is this one. Then I2 by V2 which is equal to 1 by 8 which is equal to H22. Right. So this is the way to find the hybrid parameters. So here then let me conclude this thing here. Okay, so to find H11 and H21, okay, so make output terminals as short circuit, and again to find the remaining two parameters like H12 and H22, okay, so make input terminals as open circuit. So by using these two conditions we can find the H parameters. Okay, we can find the H parameters. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.